Hi everyone, welcome to trigonometry. Today we explore lesson 16, applications of vectors. Before we do the application, let's do some review. Number one, bearing and vector component. Let's say that we have a vector v like this. Then we're gonna take the vector v as the center. And we can sketch out a vertical line and horizontal line. North, south, west, east. There is an angle theta right here. The bearing would be north 90 degrees minus the angle theta. That is the bearing. For the vector v, it has two components. We can sketch out a right triangle adjacent to the horizon or the x-axis. And then from there, notice that one of the vector is going this way. And that would be the magnitude of the vector multiplied to cosine of the angle theta. I. The second vector is this one. Magnitude of v multiplied to sine of the angle theta, j. And so we can write the vector v as magnitude of v cosine of theta, magnitude of v sine of the angle theta. One more thing, for any vector v, the component is negative if it points to west or south. The component is positive if it points to north or east. That is just how we define whether a vector is negative or positive. We are ready for the application. 2. Application in navigation. Example, a person launches a boat from the south shore of a straight river that flows directly west at 4 miles per hour. The person wants to land at a point directly across the opposite shore. If the speed of the boat relative to the water is 8 miles per hour, in what angle and direction should the person steer the boat in order to arrive at the desired landing point? So this is the boat right here. And that person wants to land the boat directly north. To sketch out the vector, first we let vector v be the velocity of the true course of the boat. Vector v sub b be the velocity of boat in still water, and vector v sub c be the velocity of the current. So that is the current vector. It's going to the west. Vector v sub c. And this one is the vector v sub b, velocity of the boat. So there is an angle theta right here. We want to figure out that angle theta and the bearing. North 90 degrees minus the angle theta is because this is the is direction. Yeah. Notice that the velocity of the true course of the ball is the sum of velocity of the ball in still water and the velocity of the current. V is VB plus VC. You can see this by sketch our parallelogram. Oh, and look at this one. This is the vector V. We're going to get the two component of vector V sub B using the right triangle. One of them is the, notice that one component point to the is direction, the other one point to the north direction. So both of them are positive. The magnitude of the vector V sub B is the speed of the ball in still waters, A, the cosine of the angle theta, A, sine of the angle theta. Now for the vector V sub C, it only point to the west, and because they point to the west, the component is negative. That will be -4. That is the speed of the water. -4 for the ith component. We don't have any j component, so that's 0. Using vector addition, we have a 8 cosine theta minus 4, comma 8 sine theta. The velocity of true course of the ball is directly north. This means that the ith component must be 0. So we set 8 cosine theta minus 4 equal to 0. From here, cosine theta is equal to over 8, which is a half, and theta is or cosine of 1, 2, which gives us theta to be 60 degrees. As for the direction is the bearing. North 90 degrees minus the angle theta is, which is north 90 minus this 30 degrees, is pretty cool problem. Let's take a look at another application. 3. Application in cable tension. Example, a 100-pound weight hangs from 2 wires as shown below. Find the tensions, forces T sub 1 and T sub 2 in the wires and the magnitude of these tensions. So to make life easy, let T sub 1 be the magnitude of the vector T1 and T sub 2 be the magnitude of the vector T2. When we look at the weight, that is the object, there are 3 forces acting on the object. The first one is the T1 vector, second one is the T2 vector, and the third one is the weight. 3 forces acting on the object. The vector T1 is can sketch a horizontal line and a corresponding right triangle. We see that this angle right here is 50 degrees. So, and if you look at the vector component, one of them must point to the left and one of them must point up. So the ith component point to the left, which tells us that the component is negative. Negative P1 cosine 50, comma T1 sine 50. As for the vector T sub 2, do the same thing and get a right triangle. We see that one component point to the right, the other one is pointing up, so both of them are positive. T2, this angle right here is 32 degrees. Cosine of 32 degrees, T2 sine of 32 degrees. The last factor is the weight. And if you look at the weight, it is pointing directly down. There is no x component, so 0. The y component is because the vector is pointing down. The component is negative 100. Since the object is stationary, what this means is, well, the sum of horizontal component is 0. That is minus T1 cosine of 50 plus T2 cosine of 32 equal to 0. Sum of vertical component is also 0. Which is T1 sine 50 plus T2 sine 32 minus 100 equal to 0. In the first equation, we can solve for T sub 2. And that will give us T1 times cosine 50 over cosine 32. Sub the T2 in here. And this gives us the T1 sine 50 plus T1 cosine 50 over cosine 32 times sine of 32 degrees equal 100. From here, you see that we can factor the T sub 1 sine 50 plus cosine 50. Sine over cosine is tangent 32 degrees equal 100. Divide both sides by the coefficient of T1, and we have T1 to be approximately 85.4 pounds. Now we sub T1 back into the equation of T2 equal T1 times cosine 50 degrees over cosine 32 degrees. And we get T2 to be 85.4 times cosine 50 over close up 32 degrees, which is approximately 64.91. How? Well, we found the magnitude of the two tensions. To figure out the tension, we just have to sub the magnitude into each factor, and we get the two tensions. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. I will see you in the next video.